Hello CS112, today I'll be going over a quick solution to Lab 7 which has to do with sets. Just of this assignment is that Huey, Dewey, and Louie all have their own collection of cards and they want to compare their cards as well as see if by pooling their cards together they can complete the entire card set, thus winning a new Nintendo Switch. UI guys were required to represent all of the card collections as a set as well as use math set theory to get the answers. By this, they just mean to use those built-in set functions. And then here you have the output, which are going to sort of be your challenges and tasks, which I've already sort of coded up here as comments to work through one by one. Pretty basic disallowed and allowed things down here, but I personally think that this lab was very easy if you were paying attention in class or even looked at the Lab 7 slides. I have them pulled up right here, and the Lab 7 slides. This slide in specific, this right here can solve this entire assignment for you, so I hope you guys were using this for reference because the slides usually help a lot. So let's just dive right into it. What cards do the Ducks have combined? Well, here is they're just like checking how their entire deck would look if they threw it all together. So that is the union of something. So we will do Huey cards dot union Dewey cards, and then we can take that and unionize it with Louie's cards. So dot union Louie cards. So what this is doing is it's taking Huey's little set of cards here, and it's going to create the union between Huey and Dewey here with the dot union. So we're going to have a union between these two sets, and then it's going to unionize that with Louie's cards. So it's going to take the union of these two sets and create a union with a third set. We can have we can create a union with as many sets as we want by just continuing with dot union dot union dot union. So I do need to print this, so I'm going to do that. We want to test it out real quick. So if I were to go down here and now run python cat.py, we would get a union of all three. Notice how all of the duplicates are gone. And something interesting with sets, if I run this again, we get a different order, because order does not matter in a set. So every time I run this, it's just going to be sort of regurgitated and spat back out, but the contents are still going to be the same, just in a different order. So now, do they complete the collection? So an easy way to do this is simply having a predefined complete setup here and checking if the union of these cards is equal to the sets. You're good to go. They have the complete collection, which means it will display this message. So I actually don't want to have to keep typing this out. So I'm going to Control-C that. I'm going to make it let's call it together. They have that, and then you'll print out together here. Let's just print out together here, and then here you can simply say if together is equal to complete sets. Then you would print out new Nintendo Switch 2 is on the way. And let's just go ahead and run that. They should be getting a new Nintendo Switch 2 if they pull their stuff together. So when we run it, we got this error. Let's just test this to see if it works real quick. So Louie is the only one with green arrow. So if I remove that from there, save this and run it, the message is no longer there, meaning that it was able to detect that it was equal to this. However, if we wanted to actually use a pure set theory notation to get this answer, we could use the symmetric difference, this guy right here, because this will check what is difference the two. This will, this will include only what is different two. And if there is nothing different between the two, then that means they have completed the set. So all you really need to do is say together dot symmetric difference. So if the symmetric difference of their cards together against the complete list, complete set, is equivalent to an empty set, then they should get their Switch. So again, we run that, new Nintendo Switch 2 is on the way. If we get rid of green arrow, easy. Not sure what happened there. Get rid of green arrow, run that, it's no longer there. So we know that that works. I'm just going to leave the this as is, with a nice little set notation there using the symmetric difference. So does Dewey have Captain America? Well, this is a simple if Dewey cards, if Cap in Dewey cards. So this is what the in operator does is it's going to compare what is to the left of it and check if it is in the container to the right. And so it's going to check if the string cap is in Dewey's cards. So I'm going to print yes. I believe it said just to print yes or no, but I'm just going to make it a little more specific. Yes, Dewey has Captain America. Else I'm going to print no, Dewey does not have Captain America. So if we're going to save and run that real quick to test it, no, Dewey does not have Captain America. If we wanted to check that out, we can, or test it a little more, we can simply add cap, and then in there, he has it. Yay. So a common error that I saw with this assignment is that I'm kind of doing kind of risky. As you can see, I'm using like Cap instead of Captain America and Spidey instead of that. But as long as you kept it consistent, this should work. I saw a lot of you guys having the right code, but then like for instance, you would have that Iron Man instead of Iron Spaceman. And then when you would compare it to the complete set, it wouldn't give you the correct answer. So that is something that was giving a lot of people issues. So just always make sure you're consistent. So what cards do all three have? So this, in order to check what cards all three have, this is going to be, excuse me. This is going to be an intersection of the three. So if we go back to the slide here, you see here it's checking what we can pretend A and B are cards, what two cards have in common. Well, we are going to find the intersection of three cards, and it's going to be very similar to this up here. So I'm just going to print out the intersection of Huey cards dot intersection of Dewey's cards. I'm going to take that intersection and intersect it with Louie's cards. So now that, I mean, that's going to work. I'm not going to test it out till the end. I'm just going to move right on to the last thing. So this is a two-step problem right here. One is it wants to see how many different cards does Huey have that none of his brothers have, and then what cards are they? So you need to print out a number as well as what cards there are. So there are a couple of ways to do this, but the first thing I'm going to do is I'm going to want to try and display what cards Huey has that the rest of his friends or brothers, I'm actually not sure about their relationship, but have in common. So I'm going to print out the intersection, the difference. So Huey, I'm going to take that and find the difference from Dewey. So that's going to take any cards that Dewey has that Huey has and remove it from the set, and then dot difference and do the same thing with Louie's cards. So if Louie has any cards in the remaining set, it won't be left. So if I just test this out right now, we can see Captain America and Iron Man are the two that what's his face? Huey has that the others don't. So if you look up here, there is no Cap in these two lists, and there is no Iron Man in these two lists as well. Or sorry, sets as well. So now we know that it's going to, so we know that we want to print out Cap and Iron Man, but how do we want to do it in a pretty way so we don't have to like have these like brackets and quotes and all that stuff. We just want to have them nice and neat next to each other. Well, the first thing I'm going to do is I'm going to, because I also want to return how many different cards there are, I'm going to say, let's say num difference equals the length of, I'm actually going to set this equal to a variable since I'm going to be using it quite often. So I'm going to say like Huey only is that, and I want to find the length of Huey only. That's going to return the number I need to report back. And then, in order to actually print these out pretty, like, I'm going to say, I don't know, let's print out the cards that only Huey has are, and then I'm going to actually separate this with little ends equals here, so I can keep them all in the same line once it is in the terminal. And I'm going to actually iterate through this Huey only set. So I'm going to go for I and Huey only. I'm going to print I ends equals, and then let's just put a space in between them. And then lastly, I'm just going to have a print statement at the end so I can have a new line added to the end of that, so my terminal doesn't look ugly. And if I run this now, as you can see here, the cards that Huey has that only Huey has are Cap and Iron Man. There isn't an ugly extra space at the end there, so I'm going to get rid of that. And if I run it again, boom, got the answer. So if you guys have any questions, feel free to ask.